Today, we will complete a full UDS Enterprise deployment, passing through the installation and configuration of all its components. And once we have the environment active, we will publish two virtual desktop services, one with Windows 10 and another with Ubuntu 18. In this specific case, we will use a VMware virtualization platform. The first task will be the upload of the different components of UDS Enterprise. These components are delivered as virtual appliance format. Specifically for the VMware vSphere platform, we will use those provided by Virtual Cable in OVA format. The first component to import will be the database. In this case, it will be the MySQL server provided by the UDS Enterprise team. We'll indicate a descriptive name and select the data center and folder where will be placed. For this case, we have created a resource pool structure to host virtual desktops. That is to say, all components and templates that will be used to deploy virtual desktops. As it is a UDS infrastructure component, we will put it in the server resource pool. Now we continue with another component, the UDS Server. We will host it in the same resource pool where we added the database. Select the storage, the virtual network, and finish the import process. Finally, we will deploy the UDS tunneler. This UDS component will be used only and exclusively to make connections from outside and also to connect to services via HTML5. Once all UDS components are imported, we will start the virtual machines, always starting with database. We will open a console to configure the IP data machine. And make the first login with the root, user and password, and then we'll proceed to indicate a static database IP to the virtual appliance. As you can see, the virtual appliance takes a DHCP address, but it's recommended to always use a static address. We indicate our network data. Save the changes and also check that the DNS configuration is correct. To take the new changes, we will restart the machine. And in this way, we will have already configured the database virtual appliance to which we will connect the UDS server. Next component to configure will be the UDS Server. We will select the keyboard language, very important to avoid problems in the virtual appliance's password. Next, we'll indicate a valid serial number. Really important, indicate that for the UDS Enterprise versions, we will use an external database, and for the free and evaluation versions, the database is embedded in the UDS server. We will indicate the machine data configuration, name, domain, an IP address, network mask, the gateway, and a valid DNS. As we have already said, when installing an UDS Enterprise version, we will be asked for the database connection data, which in this case is the MySQL that we have just configured. We will use the user, password, and the instance created by default in the database virtual appliance provided by UDS. And finally, we'll indicate a super user and his/her password to be able to access the administration the first time, and also define the password for the root user of the Linux operating system that contains UDS virtual appliances. Once the process is finished, we review all the options previously introduced, and thus we will have completed the virtual appliance configuration. The system will restart automatically once the configuration is done. After that, we'll proceed to configure the last UDS component, the tunneler server. We will select the keyboard language and designate the necessary data to confirm the virtual appliance. Next, enter the IP address or the UDS server name that we have previously configured. And finally, we will type the root user Linux password. Click the wizard Finish button and the virtual appliance will automatically restart to apply the configuration. Once these tasks are completed, we will be able to access the UDS dashboard to configure the services that we will publish. And for that, we open a new tab on the browser and connect to the UDS broker server IP address. We will use the super user created. Which will allow us to access the dashboard. The first task we'll have to perform is to register the service provider. In this case, as we are using a VMware platform, we will select VMware Center. We indicate a descriptive name IP address or our vCenter server name, a user with administration permissions on said platform, and we will perform a connection test to verify that all the data has been entered correctly. Once we have obtained a positive test result, we'll save the service provider. Next step is to create an authentication system, that is, how we will validate our users on the platform. This time we will use the internal database that is stored in the MySQL component. We will specify a descriptive name. And a label in case we have several authenticating systems to be able to make a direct access to it. Next tasks will be created groups of users and users assigned to those groups of the authenticator. In this example, we create a group called admins and a user to whom we will give administration permissions on the UDS environment, and that we will assign to the group created previously. And so we will have this component configured. The next component that we have to configure to perform the deployment will be an OS manager. This component will define what kind of configuration will be done in our virtual desktops. In this case, we will create an OS manager for a Windows operating system and another OS manager for a Linux. In the case of Windows, we will use Windows Basic, since our virtual desktops are not going to be part of a domain. And we will select if the virtual desktops are going to be persistent or not persistent. In this case, we will use non-persistent virtual desktops and indicate a maximum idle time in seconds. For example, 3,600 seconds, which is equivalent to 1 hour of inactivity. After this time, UDS will close the user's system and eliminate the service. We'll do the same with the OS manager for Linux-type machines. Next element to configure will be the connectivity part, where we will specify the connection protocols that we'll use to connect to the virtual desktops. In this example, we'll use the RDP protocol to connect to both Windows and Linux desktops and also register a type of HTML5 connection. Indicate credentials. In our case, we use an existing local user in the virtual machine template. We enable all the necessary parameters offered by the RDP protocol and mark all the display options since we are going to connect from a LAN and finish. To connect to the Linux virtual machines, we repeat the same process. We indicate an existing local user in the Linux virtual machine template and activate the parameters of interest. In this case, the redirection of USB, copy and paste, sound, display parameters, and finish. As we have already said, we also register a type of connection via HTML5. This transport is offered by the UDS channel company. And indicate the IP address of the channel server, previously configured in the format that we see on the screen using port 10443. We indicate local credentials, and enable the parameters that we'd like to use. In this case, the security type, any. Finally, we configure HTML5 transport for Linux desktops. As in the previous case, we will indicate the IP address and port of the channeler server, the credentials of the existing local user, and will enable those parameters of interest. And in security, we will use any like in the previous case. Once we have all the protocols registered, we'll need to create our base virtual machine. In this case, we have two operating system templates, one from Windows 10 and another from Ubuntu 18, ready to deploy virtual desktops based on this template. Before performing this deployment, we have to configure these services and install the UDS Actor component, which will be the agent in charge of communication between virtual desktop and the UDS server. We connect to the Windows 10 template. And proceed installing the UDS Actor component. To download it, we'll connect to the UDS portal. Using Administrator User, we can use the Super User. And in the User menu, we go to the Download section. We'll select the actor for the operating system we are using, in this case for Windows machines. We execute it and proceed to its installation. Once installed, we'll have to configure the UDS server or broker component data and also need to indicate the master key, which is a security code that can be found in the UDS administration, also tools, configuration and security section. We copied it and perform a connection test. We can enable SSL communication, and once we have a satisfactory test result, we will have finished the UDS Actor component configuration. Finally, we have to verify that the RDP protocol, the remote desktop, is enabled in our template. We apply the changes and will proceed to shut down the virtual machine Windows 10 template. Now we connect to the Ubuntu 18 template with the XFCE window manager. Validate ourselves inside the machine. In this case, we have already installed in this template both the UDS Actor component and the XRDP connection protocol. The only task we'll need to do is modify the Actor UDS configuration data. As in the previous template, we need to indicate the master key for which we connect to the UDS web portal. With a user with administration permissions, we will access the dashboard, tools, configuration, security, and master key section. We copy the key, paste it, and perform a test to see if the communication with the UDS server is made correctly. Once this task is done, we can turn off our Ubuntu 18 virtual machine template. As we have already configured our virtual machines templates that we will use to deploy virtual desktops, we will access the previously configured vCenter service provider. We will select it, and on the screen that appears below, we click on Services and create a new service based on link clones. We will first create Windows 10. Select a data center, a pool of resources where virtual desktops will be created. Select the storage where publications will be created. And in the machine section, we will indicate which template machine of the two we are going to use. In this case, it will be Windows 10. We will indicate how much memory the self-generated virtual desktops will have, to which network they will connect, and the data stores that will be used to create virtual desktops. We will give a root name and a length. In this case, we will use 2 digits, which will allow us to deploy 99 machines. We perform the same task for our Linux service, specifically Ubuntu 18. We select the pool of resources where our templates are hosted. Ubuntu 18, RAM, virtual network, data stores where virtual desktops will be created, and the DNS name of the machines. In this case, Ubuntu, and with 2 digits. Once we have created our service and the rest of the components, we can already perform a desktop deployment. We go to the Service Pool section and click on New button. We type the name of the service. This name will be the one that appears to the final user when do the connection. We select the base service previously registered, in this case from our vCenter provider, and then Windows 10 template machine. Also the Windows Source Manager. And we will indicate some cache values. How many services will be there initially, how many services will always be maintained, and we also indicate the maximum number of services to be deployed. Then we save the changes. Automatically, the system will start creating the first publication. If we go to the vCenter, we will see that the first task that is done is the cloning of our template and the creation of the first publication. Once you finish creating this publication, the virtual desktops indicated in the cache section of the service pool will be created. We now proceed to publish the Ubuntu service. In this case, we select the vCent provider with the Ubuntu 18 template machine, the Linux OS Manager, and in this cache tab, we select the services that we will initially have and how many services we will always keep in cache, and as in the previous case, the maximum services. Upon saving, the cloning and generation of virtual desktops will take place. As you can see, the publication of the Windows 10 and Ubuntu 18 services are being created at the same time. We wait for these publications to be created and we'll see how the new services are created. Once the publication is finished, UDS will begin to create virtual desktops that we have indicated in the definition of the service pool. The system will start creating virtual desktops, booting and configuring them. If we go to the UDS administration, we can select the services and we will see that in the Publication tab, we already have a publication in a valid state. And in the Cache tab, we will see how the new services are being created. At this point, the virtual desktops are starting up. They are configuring their new DNS name and they are applying all the configurations that we have indicated in the OS Manager. As soon as we have a valid status, it will be possible to connect to these services. The next step that we have to define in each of the services is who will be able to access. In the Groups tab, we add the one that we have previously configured in the Authenticator section. In this case, we will select the internal authenticator and the group created, admins, and how are we going to connect to these services. In the Transport tab, we will add HTML5 for Windows and RDP for Windows. And in this case of the Ubuntu service, we will perform the same tasks. We will check in the Cache tab the status of the virtual desktops generated with the two services that we have indicated in the definition of the service pool, which, as we see, are already in a valid state.
And if we go to the Windows Service pool in the Cache tab, we will see that we also have the 2 desktops available. If we switch to the vCenter view, we see that we have here the 2 Ubuntu and the 2 Windows machines ready to make the connection. Now we'll go to the user dashboard and we'll connect to the services. We leave the control panel and we log in with a user belonging to the admins group, who are the ones who have permissions to see these services. As you can see, the Ubuntu 18 and Windows 10 services already appears, and in both cases a GUIL appears because we have 2 different types of connection protocols defined. In this case, we will connect first to Ubuntu 18 through the RDP and automatically connect to the Linux virtual desktop. If we log out, as we have indicated that it is an operating system virtual desktop, we see that UDS automatically deletes the service, and when we reconnect, we'll see a new desktop. As we have indicated that there are 2 desktops in cache, UDS is automatically creating a new machine, in this case Ubuntu 02. In the vCenter, we can see how the Ubuntu 00 machine to which we were connected has already been deleted. Now we will connect to the Windows service through RDP connection protocol. We log with the credentials indicated in the transport and connect to the desktop. Now we will make the connection through the HTML5 connection protocol, first to Ubuntu 18 machines, which will allow us to open our virtual desktop inside the browser. And we will also connect to the Windows 10 service through HTML5 connection protocol. At any time, we can access the dashboard with an administrator user and control the active session in the Assigned Services section that our users are assigned with a tracking log, where we can see when a user has logged into the service. And, if necessary, we can manually remove this assignment. As you have seen, the configuration of VDI platform with UDS Enterprise is very simple, and we have it up and running in just over 30 minutes.